Hello everybody. I hope there's somebody there. I'm speaking to a camera. Welcome to this presentation on app modernization in Azure. If you have any questions during the presentation or session, please ask them in the chat and let's see if we have time to answer those at the end. I'm Sakari Nahi. I'm the CEO at Azure. I'm also a Microsoft Regional Director and an Azure MVP. These two titles come from Microsoft, and they are something that are given to people who are somewhat visible in the community. They can be a little bit confusing, especially the Microsoft Regional Director bit, because I don't work for Microsoft, nor do they give me money. I don't have a region, and I don't direct anybody. But still, they let me see something more inside Microsoft, so I'm glad about them. There you can see my Twitter. Please reach out to me if you have anything. And otherwise, if you are not already part of, for example, Finland Azure user group, please join. You can find it from Meetup and all of our material, especially now during Corona when we are creating videos, we upload those to YouTube into Finland Azure user group channel. So we have about 1,800 members in FAUG already, and you are welcome as well. The other thing I like to do regularly is Ikkuna Studio, a podcast in Finnish about Microsoft, where we have an episode every week and a half. Every other one is about news, and every other one is a long format interview. Zure is a company that does 100% Azure. Our purpose is RORA Challenge. We try to solve things and problems that are not easy, where we have no ready answers. So we look to build and create something elegant, something we can be proud of. And of course, sometimes we fail, but we hope that the next time we succeed when we retry the same thing. We have 60 experts who work on Azure, and the average experience of IT on those experts is 14 years. We have a bunch of gold certificates. Our offices are in Helsinki, Finland, and also in Ghent, Belgium, where we expanded last year. At Azure, we have 4 Azure MVPs employed, and to put that in perspective, in Finland, there are 5 Azure MVPs total. Today, we will first look at app modernization in general. Then we will look at some approaches by different types of models that we define in the first step. And at the end, I will walk through 3 cases in production about different kind of maybe a little bit more complex modernization cases. And then, as said, if we have time, let's look at your questions. I don't think we should start to talk about digitalization and the need for it. It is pretty clear that your management and the organization leadership are all going to go the digital way. Everybody is digitalizing. If we want to say something, we could say that all companies do software. No company is exempt. No business can thrive without software nowadays. So all companies need to be aware and understand the producing of good quality software solutions and applications. The other bit is that information is key. So when we have data in our ERP, let it be SAP, and we have data in CRM and PLM and other core systems like that, it is for the future, it is meaningful to start aggregating that data together, to validate that data with business rules, and in the cloud do advanced analytics to get intelligence and to be able to make decisions on the data. So those 2 things are important and meaningful and significant in companies right now. And when we go forward with the modernization, it is clear that these are impactful there as well. Now, if you look at reasons for modernizing an application, Gartner gives us 6 reasons. The first 2 come from the fact that business changes. As time goes on, businesses change and the business models change. And what Gartner says that an application might have a lower business fit or worse business fit or worse business value, meaning that the application got so old that it's not useful anymore. Maybe the application is hard to develop. It might be old enough that there are really no developers available, or maybe the time to value is so long that when someone wants to develop something, the business just waits for years and nothing happens. and this leads to lessened agility. If we think of business today and business is changing, our tools and applications need to follow those changes as well for us to be competitive. Now, from the more technical side of view, we can think that the platform or hardware, they come to end of life, or they might become too costly, or the maintenance might be costly, and that leads to high total cost of ownership. This might necessitate a app modernization process. Another hard to develop or too high feature cost might be caused by high complexity of the application. An application might have grown organically during the years, and this might cause an application to grow up to be so complex that it's hard to develop further. And this is another technical reason to modernize an application. And the third one, especially if you are working in the banking or finance world, EU and other places, other organizations give out new regulations, new security requirements. There might be some demands on the way the application is supported, or maybe partners are part of it, or maybe the application simply has so many users that it needs to scale globally, or maybe it needs to scale temporally. And this might lead to a risk of failure in an application, and the application might need to be modernized because of that. So those 6 points on the right are Gartner's view. First 3 are business reasons, and the last 3 are technical reasons to modernize an application. Now, if you have an application that needs to be modernized, what do you do? How do you start? First, you do an assessment. You look up the application and you come up with some kind of a result. And if the result is that the application is so crap that nobody wants to use it and it's really not useful, then maybe think about modernizing. The end goal is pretty clear as well. You want to have a modernized application that is a joy to use, and it has a lot of business value, and the total cost of ownership is low, and you need to know that this application can be further developed. So what's in between? Unfortunately, in between part is the difficult one. In between part, you gotta do something. So I guess you modernize a lot, and it becomes something like from the South Park when we had the underpants gnomes who collected underpants, and they were pretty sure it's gonna lead to profit. They just weren't sure on how that might go there. Let's try and solve this second phase today. Now, this is the first, a little bit more complex slide. In this slide, I will try to put together the views of Gartner and the views of Microsoft into modernization and into cloud maturity, into application cloud maturity. There are a little bit different approaches, but you will see they tie in together pretty well. If we walk through the Gartner approach first, Gartner has 7 different options into modernization. The first one is encapsulation. It means that there's a system and the system itself is not modernized. Let's say it's an ERP system. Let's say it's SAP. And you encapsulate that by providing data and functions via APIs. The second one is where you really do something for the application. You rehost it. So you redeploy it in another environment, in Azure, in AWS, in Google Cloud, in another data center, whatever. But that's the first step of real modernization approach. So you redeploy application without modification. Replatforming is kind of similar. You don't change the code, but you do update the runtime. So you do some versioning upgrades so it doesn't rot in your hands, the application. The next bit, refactor, means that you do something with the application source code. You refactor it to be more elegant. You remove some of the technical debt that usually creeps in applications as they grow older and more complex, but you do not add new features. Re-architecting from Gartner point of view means that you do add new features that the business needs. And let's face it, if an application is modernized with refactoring, I've never seen a case where there isn't a bit of re-architecting. So usually business wants new features as well if something is done for the application. The next bit is rebuilding. So you rebuild the application, but the scope is good. The application idea is still a fit for business. So you keep the scope, but the application itself has technically stagnated and it's not good enough anymore. So you rebuild the technical side, but the scope and the audience is the same. And the last option is replacing that application. And there you forget the scope, the previous scope, you create a new scope, a better business fit, a scope that better brings out business value, and then you implement that one. So these are the Gartner modernization options and modernization approaches. Now let's look at the Microsoft's cloud maturity model. So it looks at applications on how mature they are when looked from the cloud viewpoint. It's a little bit different. It's a little simpler, I think. So first, Microsoft recognizes there are applications that exist and are on-prem. That's nice of them. And basically, those are legacy applications. And Microsoft also understands that some will be phased out. Not all applications will be modernized. And this is actually something that seems to be missing from Gartner viewpoint, I think. I think we could add their phase out before encapsulate, because if you have, and if you do an assessment on an application and thinking about modernization, well, certainly the outcome can be that, hey, let's phase this out. Let's not modernize this application at all. So now we added phasing out to the Gartner timeline. The next step is lift and shift. In lift and shift, it's a quick step it's a quick step for an application to be lifted, usually to virtual machines. It's rehosting or re-platforming from Gartner point of view, and that might be the first step in getting application modernized. Next step from Microsoft maturity point of view is that the application is optimized for cloud. In this scenario, the application has been refactored and restructured so that it really works with the cloud. And also it might take some advantages of some of the cloud capabilities like scalability, or maybe in on-prem it used SQL Server, in the cloud it starts using Azure SQL, and that way we don't need to administer the SQL anymore. It comes to us managed by Microsoft. So those kind of things are cloud optimizations naturally. They lessen our workload. And the last bit on the maturity model is a modernized application, app modernized, which would, from the Gartner point of view, be re-architected, rebuilt, or replaced application where we fully utilize the cloud's capabilities in building the application. To really round out and complete this picture, I'd like to add SaaS. Because if you think from the Gartner point of view and you forget the scope of the application you are modernizing, you need to really change the application, then one option is, of course, to buy that software or application out of the box. Get it as a software, as a service, and then you don't have to mind about it at all. In this presentation, we will walk these modernization approaches through the Microsoft Cloud Maturity Model more. The four different stages are clearer and less granular to understand than Gartner's specific steps that have more of the technical differences. Before we go there, let's look at the different cloud services that the clouds provide. And this is a slide you have seen, but now I've tied together in this slide the maturity models. As you know, if you have your on-premises data center, the unit of scale is hardware. You buy hardware, then you install virtualization and operating systems on it. And if you want to scale, you need to buy more hardware. And that is, of course, existing apps on-prem from Microsoft's point of view, if you think of cloud maturity. The next step is infrastructure as a service. You buy virtual machines from the cloud, and there what you manage as an organization, you manage the operating system. And this is lift and shift. So if you do a lift and shift modernization, you lift to infrastructure as a service. Next is containers or containerization as a service. Here, basically, you don't have to worry about the operating system. It might be Windows, it might be Linux, but you do have to worry about the container image, the container runtime, the container registry, and you define the runtime over there, and you scale by adding more containers. Next step is naturally platform as a service, where you have less administering than in containers as a service. There you define, you deploy and define and manage your applications. And if you want to scale, you want more applications, just push more applications into the cloud. And the last step when we are thinking about using cloud traditionally is the functions as a service, where you use usually serverless components or some microservices where you push these atomic single purpose functions into the cloud. And then when you have 100 functions in the cloud, maybe 30 of them fulfill a purpose of a single application. That's why application there is black, because the application is built out of those functions. Now these three cloud service types, containers as a service, platform as a service, and functions as a service, are where the optimized and modernized applications live. So from lift and shift, you move to these three. Maybe it could be roughly categorized that the optimized applications are more on the containers as a service side, and modernized should use more of the more native and sophisticated features, just like functions as a service. And basically it would mean that the organization itself has less and less of administering to do. But that's a very hard categorization to really say, because if you look at some of the most modern applications that are being built right now, they really heavily utilize containers as needed. So it is hard to state that optimized applications would be on containers and modernized would be on PaaS and FaaS. To complete this picture, again, just added the software as a service. If you buy the service, you pay for the management and you don't have to care about anything. Now we'll start walking through. We'll walk through 4 different approaches, and the first is lift and shift. It is the easiest to understand. There we have the lift and shift from the Microsoft point of view, and from the Gartner point of view, we are talking about rehosting and replatforming, so no changes to code. And lift and shift is the least effort move to cloud, and you move the app as is. So if your application on-prem is the Windows, Linux, .NET, Java, it has the SQL Server, MySQL, PostgreSQL, whatever it has, you just get virtual machines from whatever cloud you want to lift and shift to, and then you are set. That application lives there and it is the same. The benefits are the project should be quite speedy and quite straightforward. The old know-how, well, much of the old know-how of the organization still applies, but there's no changes to the code base. So that's a benefit. Also, you get a global deployment. Azure has over 50 data centers. I think there's like 52 or something, and every year there's more and more. So if you feel like your customers are in southern France and your current deployment is in, let's say, Finland, then you could deploy, when you lift and shift, you could deploy to southern France data center and thereby get closer to your customers. So this global nearness or reach could be reached with this lift and shift. Lift and shift as a name is funny. I don't know what the shift part means, but the lift part is pretty clear. The detriments to this are there's no benefit to scalability. If your app didn't scale on-prem, it probably won't scale in the cloud. Of course, in the cloud, you can upgrade vertically the servers easier, so maybe that helps. There's no new features or capabilities to boast to business, and there's no DevOps. If you didn't have DevOps, if you did manual deployments before, you will do manual deployments in the cloud as well. And that's a big detriment, a big disadvantage. DevOps by itself, the approach to DevOps, the ability to do quick cycle of innovation, to do automated deployments and infrastructure as code, that is something that every company should strive for to keep the agility up. So when would you use lift and shift? When speed is a requirement, your hardware is end of lifing, go lift and shift. Maybe you have 100 applications and you try to modernize some of them. You can't modernize everything at the same time. So maybe your application is of lesser priority. So lift and shift if you want to do that. And then some solutions require the control given by virtual machines. If you need control on the operating system level, then this might be the way. A while back, we did a project Azure that was about, it was a physics simulation application or solution, and it simulated fluids and maybe even airflow or something like that. And that needed a virtual machine to go. We actually helped with the scalability a bit by doing Azure batching, and in that way we could easily set up several VM environments simultaneously to do different simulations. And that was kind of a fast and dirty solution when it was not possible to recreate the solution that had been created during a 10-year by physics professors. So that's lift and shift. Encapsulate. Let's look at this. Encapsulate is not really part of the cloud maturity model by Microsoft, clearly, because if you have, let's say, the SAP that I used earlier, if you have SAP and you don't move that anywhere, then the maturity of that application does not change. Encapsulation, however, where you create APIs that provide data or functions from the application or system in question, it is very commonplace and powerful tool. And that's why I wanted to have it in this talk presented. Basically, and especially, it's very useful with systems that can work in an event-driven manner. Like, let's take the SAP again. You have a developer who knows how to do ABAP or whatever is the code inside the SAP. And this person can create a trigger that whenever a certain type of transaction happens in the SAP can send that payload outside of SAP. Now in Azure, we might have an API that fetches and receives this payload and stores that into Azure Data Lake, for example, as part of the source sets or source data for a training model in machine learning services. And maybe this machine learning services is about forecasting customer behavior, or maybe it's about predicting maintenance needs or something like that. And the transaction all the time enriches the training model, which makes the scoring and the prediction of the advanced analytics more precise and better, more confident. So, and as you heard, as you think about this kind of advanced analytics is very native and very good to build with cloud, public cloud, because big data and so forth makes sense to do it in the cloud because that scales cost effectively. But you might not want to transfer or migrate your ERP as the first step, and this might be a very efficient way of doing something intelligent. In these kind of scenarios, the serverless approach is usually a fit. And by serverless, I'm talking about Azure Functions and Logic Apps, that kind of services in Azure. In Amazon, we have AWS Lambda, and those, if you are more familiar with Amazon. And this serverless approach is fit for purpose because if some system sends or triggers some kind of a data transfer, then it's easy for the serverless components to wake up, handle the thing, store the data, validate the data, do something, and then go to sleep until there's a new transaction or new change. I see that there are some questions coming in, not all of them published. I will look at them after the speak, and that's very good. Let's move on to cloud optimized. So cloud optimized is the stage after lift and shift, and it's cloud optimized applications. Basically, you've had an assessment of the app, and the assessment says, usually they say, hey, app still works for business, it's good enough, but business requires new features for it to really bring out the business value. So for this segment of the talk, I thought we'd go through two scenarios. The first scenario is where we have a modernish application. It's low to medium complexity, It's basically a web app with SQL and some files. That's like 80% of not the big applications, the smaller business applications in corporations. It's less than 10 years of age, or maybe less than 15 years, something like that. It's pretty modern, but it's not from the 90s. It doesn't have any crazy usage peaks. So on the third Monday of the month, there's not 10,000 users suddenly, and it doesn't have the global scale. And there's no need to change the core architecture. So that's the modernish application scenario. The other one we look at is application that's old and weird. So that's some app that is being used by some business still, and it's generating some business value, but we don't have any developers who know what's in it, and we don't actually know where it's running. It's just a couple of servers we don't dare touch because someone uses them. And we know there's some special modules like map server or something like that, just some component, open source component that runs on something specific runtime and so forth. And this application in this scenario is old. It's older than 10 years of age, and it hasn't been updated because, well, no developers, like I said. For the modernish, we decide to evaluate using platform as a service services. We are like, okay, it's a web app, it has SQL, it has files. Well, sounds like something there should be, pretty native comparisons or comparative services in the cloud. Modernization with PaaS services, the pros, if it's a fit, there's no need to rewrite the code. You get the full DevOps approach, and I recommend you go that way. You get scalability benefits because the platform as a service components scale very nicely in the cloud. You don't have to worry about the administration. There's no need to administer platform as a service components, and there's no infrastructure work. Well, there might be some if it's a hybrid application and you need to get some data from on-prem, so there might be some networking for that to happen, but there's no infrastructure in the cloud. There's no traffic routing for the messages and so forth. The con on platform as a service components is, of course, less control. If you use app service as a location, as the runtime environment for your code, app service, it's a service and it is what it is. It's, it has a lot of features on domains and certificates and security and everything, and it's very, very competent and full package, but it's not something you can modify to your heart's content. If we look at some easy transfers in the platform and service space, if the application you are modernizing has Microsoft SQL, then you would look at moving to SQL Azure, which is pretty close to a match to SQL Server, and that would be managed. So you would have less to manage. Now, of course, if you use SQL Server, SQL Server's instance level capabilities like SQL Server Agent or maybe cross-database querying capabilities or stuff like that, SQL Azure doesn't have those capabilities. So then you would go to SQL Managed Instance, which is still a managed SQL for you to enjoy, but it would be a little bit different from SQL Azure. But that's what you would think about if you had SQL. If you would have PostgreSQL or MySQL, you would first look at Azure Database for PostgreSQL or Azure Database for MySQL. Those are both something that are being maintained by Microsoft. So there are these managed services for most used database out there. MongoDB, you might look at Cosmos DB, they have MongoDB API. Java .NET application, the application source code is some language. You push that to app service. It might be Python, it might be Ruby, it might be some others that there's support. So you would look at that. Then you have the files, you would push those to Azure Blob Storage or Azure Data Lake, which is basically the same service, except Azure Data Lake has some more toggles on, so it gives some more features on the access control and so forth when compared to Blob Storage. Maybe your application has some message queue like RabbitMQ, which is very much used service. You would transfer it using Azure Service Bus, which is pretty similar, even the terminology goes together like topics and stuff. Or if you want more event-driven approach, maybe you take Azure Event Grid. And then you get some more plumbing around the application, Azure AD for the Azure access, and maybe if your application has internal user management, authentication, and so forth, you might think about using Azure AD as an identity provider. You could get single sign-on if the organization uses Azure AD or Office 365. You would get single sign-on to your application out of the box. Pretty nice. Application insights for telemetry and application debugging, Azure DevOps or GitHub, of course, GitHub or GitHub Enterprise for DevOps practices, and then Power BI in case your SQL has some data the leadership would want some reports on, and you don't want to do that inside the application. Just plug in Power BI and start tracking components. Just a fast overview, for example, on the Java. If the application you are modernizing is Java, you can see that versions 7, 8, and 11 are long-term support. 8 goes to 2030, and this is supported by App Service by Microsoft. And the new versions 13 and 15 are on a faster cadence. They are on medium-term support. So if you have an even older Java app, then you got to think about something else than App Service Direct. So the modernish scenario result is that you have your Windows or Linux-based application done on .NET or Java or Python. It has a relational database of some sort. It has some files, maybe it has a background task, a cron tab, something is doing something in a scheduled manner. So you turn it into platform as a service, you get app service, which is the first globe or ball looking icon there. Then you pick up the correct managed SQL relational database from Azure. Then you get data lake or blob storage for the files, the object storage, and then Azure functions for the background processing in a scheduled or triggered manner. And then you do the DevOps approach via Azure DevOps or GitHub Enterprise. So that's the modernish. In old and weird, we already know that, my God, there's old source code in it. There's some weird modules, and we don't know really what's going on. So we'll evaluate containerization. We get a feeling we need to be able to define the runtime, and the Java is older than what app services support. So modernization with containers. On the pros, the first 3 bullets are the same with platform as a service, and the next 3 bullets are a little bit different. There's increased density. So if you have your containers in a cluster, in a farm of servers, you might push more containers into this same hardware, and that would increase the density and raise the effectiveness of having applications in the same hardware, so to speak. Portability is very much a key with containers. If you have a containerized application, like fully containerized, which is very rare, but still the source code bits of it, they can be put to run anywhere in your data center, in Azure, in AWS, in Google Cloud, and so forth. And it supports runtime. So that's the nice bit about containers. You can really define and control the runtime wherein your application is. The cons are the learning curve is steep. The containers, there's a bunch of, you get containers, you get Docker, then you get like container images, you get container registries, then you get Kubernetes, then you start get app management like Helm and Istio for traffic control, and it is its own whole new world. Because of these components, I just said the architectural complexity may rise. You will have more moving pieces in your application when compared to platform as a service or the old world. And because of that, you will have more administration when compared to platform as a service because there's more pieces. I put an anthill there as a picture. I don't know why, but it still feels like a good idea. So the old and weird. So it's an on-prem solution running on Linux. It has some old Perl, it has some old Java, it has a separate map server implementation, and it has PostgreSQL database. That's the elephant. And the result is that we will modernize it on containers and platform as a service. And that's actually the usual result when we think of something that requires containers. There will be containers and platform as a service. So there you will have the Docker containers, the steering wheel of the boat, that's Kubernetes icon. So Kubernetes is used to orchestrate if there are several containers. Helm is package manager for for Kubernetes. Istio is service mesh, so it basically manages the traffic flow and networking between the containers and so forth. So if you have multiple containers, and in this case we would probably have the Perl environment, the Java environment, the map server is a separate and so forth, it might be that we would use Kubernetes, and the Kubernetes would be running on Azure Kubernetes service. So the Kubernetes itself would run on a managed service. Now, if it was a simple one container application, we would actually think about app service. So that's again the round thing outside the box on the right. So that by itself might replace the Kubernetes Helm and the Istio sailing boat. The sailing boat is Istio. And that way it might simplify the architecture a little bit. On the bottom, we have the platform and service components. We have the managed PostgreSQL database, because let's not do that by ourselves and manage ourselves. Then we have data lake for files or Azure Blob Storage. And then we have Azure Functions for background processing and these serverless workloads that are very heavily used with container application as well. And then, of course, DevOps and GitHub handle the Azure DevOps and GitHub handle the DevOps approach. Now, what's noticeable here is that the container-based applications are portable. They can be ported to different clouds and environments, like I said, but still container applications that are being built nowadays organically, they use platform as a service components. So it is not as if the application could be taken and lifted elsewhere in a minute, because there are these tie-ins to the cloud platform. So basically here the Azure database for PostgreSQL would, if that was moved to AWS, that would go to some other, the data lake would go to Amazon S3, and the Azure functions would be ported to AWS Lambda and so forth. So there would be this kind of a project, which is good to understand, because there's a lot of talk about containers and the freedom of movement containers grant. But it's good to know that in real world it becomes a little bit more complex. So the design results on optimizing these two types of solutions was that the other one goes to platform as a service, which is of course then Azure specific implementation, but needs no maintaining or administering. And then there's this old and weird, which would be containers and platform as a service combination, which requires some more administration, but it still runs. So now we see that even in a little bit more difficult scenarios, we can find the modernization approach to cloud. Let's look at the last step next. Modernized apps is the last level of maturity in the Microsoft Cloud Maturity Model. And from Gartner point of view, it is about re-architecting, rebuilding, and replacing an application. And with modernized apps, you really get to use fully the cloud capabilities. You might be interested in thinking about microservices architecture and event-driven design and going towards CQRS or whatever is the complexity that your application requires. And you might be wanting to create a data-driven organization with advanced analytics, with the capability to get data from those data sources like SAP and CRM and PLM and MDM and all of those places, and aggregating that and validating that with business rules, and then using that as part of advanced analytics and providing that intelligence via applications or reports. So modernized applications provide those kind of capabilities. Now I'm going to walk through 3 case examples. Serra, where we did an ERP modernization via carve-outs. A carve-out is something where a feature or a function is identified, and that is then replaced by a more modern or a different kind of approach. In this scenario, we modernized the ERP functions via Azure capabilities and Azure applications. Lanciata, which was a CRM modernization via encapsulation and advanced analytics. So we provided some data from CRM and created some advanced analytics solutions on that to help the salespeople. And then Valmet, where they have ERP renewal ongoing, and they needed to modernize the supply chain, the digital supply chain tooling. So those are three cases I'll walk through, and there will be 2 slides per case. Seure. Serra is a company that offers work opportunities in Greater Helsinki. So they basically lease workforce to hospitals, daycare, schools, and places like that. And the lease might be 1 day, 2 days, a week, a month, a year. So it might be short or long term. What they do is they provide workforce to 3,500 locations for 15,000 people. So that's a lot of management. If you think about the amount of work that needs to be done to place all of these people and for them to find the place where they would like to work on Saturday and Sunday, that requires some orchestration. Now, this here is an architecture diagram and one picture of the mobile front end we've created. Unfortunately, the mobile front end is in Finnish, but it is basically the worker mobile on top that we have a picture of here. And there we have a worker who works or who has the capability to work at a daycare. And he has clearly been searching for daycare opportunities to work on those days. And then he finds some daycares where his help would be needed, and maybe they're close by and easy to get to and so forth. So the modernization was started from the ERP point of view. There's a number 1 there at the bottom, and the ERP did not have this kind of capability for the workers, this kind of modern approach into being able to orchestrate and design their own workday and work week and so forth. So we started creating and concepting this idea, number 2, on the clients. And once we were clear on what we want to do, we created APIs that fetch data and communicate with the ERP with the required data. And these APIs then function as a backend to the mobile app. In addition, you get some plumbing out of, with that kind of API project. We got Azure AD, application insights and stuff like that. And then we needed some serverless workers, Azure functions to do some kind of background processing. After we got that working, it was clear that we needed some data in the cloud as well, some metadata, and some new kind of data was born out of the usage when people use those applications. And so we put up the storage, its own storage in the cloud, the SQL and storage blob. And once we had new data there, we had data from ERP and we had new data about how people behave and what the business is doing, then we could do some advanced analytics with Data Factory and Databricks. And that's actually been a big push with Serra to really automate the placement and matching of workers and jobs. If there's 3,500 locations and 15,000 workers, automating 80% of that matching will save quite a lot of time. So this has been Serra's need, and they are very happy being able to provide these new kind of user experiences and also automating some of their own work with this modernization. The next case was Lanciata, growing car industry company that do everything with cars. They sell, fix, lease, rent, and import cars to Finland. They are one of the top 5 car companies by revenue in Finland, and they employ over 500 people. The modernization started with the realization that the key to a successful car business is about the leads and the actions of the salespeople. So Lanciata really wanted to ensure they give proper support to their 150 salespeople. Let's say I'm a car salesperson and I know someone who buys a car every 3 years, and I know this person bought a car last time 3 years ago. It would make sense for me to call her and say, hey, you might want to buy a new car. Here's actually the kind of car you recently bought, like last 2 times, and we actually can give you a pretty good offer on that one. So that would be good service. And that was the goal. The goal was to improve the efficiency by giving these kind of intelligent leads to salespeople. And at the same time, the leadership team, of course, gets information on the actions of the salespeople. So it was clear that the salespeople needed a new mobile app and the reporting could be done with the web app. And what we did then, we encapsulated the source systems, the relevant source systems, the maintenance systems, and the CRM. There was some development on the API, but on the main, we used Azure functions to transfer data to Azure, and we directly collected data from their data warehouse. And then we, around that data, we built the capabilities of one, providing APIs to the mobile and web apps. As an app service backend, we had Azure function workers to do the data aggregation and validation and transformation and all of that stuff. And Azure Databricks was used to do the machine learning model and really do the predictive and scoring of the leads and so forth. And this application has been impactful with the sales, so it's been a success. The last case is Valmet. And Valmet is a large supplier of different technologies. They have 3.5 billion of net sales and over 13,000 professionals, and they are also a listed company. Their modernization was to be implemented in parallel with the ERP renewal, like I said earlier. And Valmet operates several warehouses globally, and we are talking tens, maybe even hundreds of warehouses, because there are some site-specific warehouses as well. And successful delivery of services and logistics require, of course, up-to-date understanding of what's where. If I'm going to deliver an equipment that requires 1,000 pieces of hardware, like nuts and bolts and sensors and everything, I really need to know from which warehouse I can get the required pieces to be able to build and deliver that equipment. Valmet's ERP renewal project mandated the modernization of the previous supply chain management tooling. And of course, they could make a business call to either way. They could do that tooling as part of the ERP, so it would be inside the ERP, or they could have decided to do a separate entity in a common layer of some sort and maybe get some shared capabilities or benefits of that. Valmet's call was to modernize this digital supply chain tool outside of ERP and on Azure platform as a service. So the ERP provides an API that was being developed on, and Azure was used, and we built the capabilities there to provide and the mobile software for warehouse workers and logistics operators. And there's a real-time integration with the ERP, the Azure functions and other integration components there communicate with each other via Azure Service Bus and Event Grid, and also Power BI, which is not in this diagram. Power BI is used to report according to some of these data transfers and data payloads. There's its own metadata in a relational database. Monitoring and security are of course paramount in this kind of a project, to know where something goes wrong and what is being done wherever. And also the API backend for the React Native frontend that we built is in Azure. From Azure point of view, what is a modernization project? It is an assessment first, which take us from 3 to 4 calendar weeks, and we answer the questions like, should and could this app be modernized? What would it look like in the cloud? What would be its architecture? How long would the modernization take? How much would it cost? What would be the TCO in the cloud? How much would it cost to run in the cloud? And if those answers were satisfactory, then organization decides to do the modernization, and then it's implemented. So simple. Takeaways. Last slide. Prioritize app portfolio. If you have a lot of applications, you cannot modernize all of them. You should not try to modernize all of them. Maybe you optimize some and you lift and shift some. So find your applications and prioritize the ones that really bring the benefit and the business value. A simple lift and shift, even though it is only to virtual machines, it can be a suitable first step for many apps, especially if your data center or on-prem is having end-of-life issues, or maybe it's a strategic push by the management to really go to cloud. The more meaningful the app, the more it has business impact, the better candidate it is for modernization, because with modernization you can take benefit from a more leaner and faster and more robust, more reliable, more scalable architectures, and you can also think about advanced analytics and data-centric development. The right approach, when you do it correct, it yields you more scalability, both global reach and also, it's Black Friday. If you get customers a lot on Black Friday, you want to be prepared for that. So that kind of use peak scalability, more reliability with the SLAs and the snapshotting and the disaster recovery and all of those capabilities that are in the cloud already. The agility with the DevOps practices and approach to be able to stay up to date with the business requirements, and intelligence, like said earlier, when the data is aggregated in the cloud, it is easier to see and use that data to find new insight. That was it. I spoke quite fast. It took us 50 minutes. We have a few minutes of time to look at the questions. There are two questions, both on encapsulation. Could you be more verbose on encapsulation? And then there is, in object form, we encapsulate the data in form of public, private, and protected. So I think these might be from different. These might be different questions. Both speak about encapsulation. The people who make these questions, feel free to clarify those, or if you want some more information, I spoke a little bit more about encapsulation on one of the cases. I think personally that encapsulation, the way where you keep your core app where it is and provide data and functions via APIs to cloud, I think that is a very good way to go forward. Migrating or updating ERP or CRM or any of those core business systems, it takes time. It takes so many years that if the opposite way of approach is to create an API and then have something visible in, well, depending on corporation, but let's say from 2 to 4 months, it's quite different time to value, and that's meaningful. The other one, in object form, we encapsulate the data in form of public, private, and protected. I'm thinking that might be talking about the data storage. So talking about the kind of approach where if you put data and when you put data, and it is pretty regular that the staging area, the raw data storage for corporation is a data lake. You put data into data lake, and it's an object storage and it can store anything. And with Azure Data Lake, you can tie access control to data lake with Azure AD, meaning that you can grant access to data for certain security groups or certain people. Then that data already in data lake in the staging area can be categorized in different types. In the chat, there's public, private, and protected, for example, types of data, and that could then work as a basis for the APIs and applications. So the data could be safeguarded and secured from the data storage up, which is pretty nice, because usually that kind of capability is on the application level and not on the storage level. I have no clue if I answered to the right questions, but I think we are pretty much done. Thank you, everybody. Reach out to me in Twitter, for example, @sakarinahi, or via email, or whichever way you want to, and I'll reply. Thank you and have a nice work week, everybody. Cheers.